few students also were confused with respect to non-preemptive SJF. I'll just quickly give you the idea how exactly your non-preemptive works, right? For example, if I have a process P1, P2, P3, and P4, I was having the arrival time, which was given over here. Burst time is 7, 4, 1, and 4. Now, whenever you are talking about non-preemptive shortest job first, non-preemptive indicates that whenever we talk about non-preemption, it means it is basically executes the your exam question is asked based on non-preemptive. First of all, whoever process came first, arrival time was 0, so P1 will start its execution. Later on, you have a burst time 7. So if I start from 0, let us say it will end at 7. Normally, a Gantt chart is started from 0. So P1 will finish its own task. If you observe, now the time is 7. So by the time 7, process P2, process P3, process P4 have been already arrived, maybe at 2, maybe at 4, maybe at 5. So that means by the 7th time duration, all the other 3 processes have been arrived. So for this, now we have to decide which process we have to go for. We have to go for whether next process as P2, P3, or P4. The processor will observe the algorithm is shortest job. So the job which is shorter one is nothing but P3. So the next chance will be given by the dispatcher from ready to running queue is to P3. Since it is non-preemptive, so P3 will complete its execution. Its burst time is 1, so it will be given as 1, that is 8. After that, I have again P2 and P4 are remaining. Both are having the same time duration. So in this scenario, P2 will first get executed because it came first. So in case of, I'll just check the mic. Maybe the voice is little low. I'll check the mic. Okay. Is the voice okay now? Everyone? All right. So when you talk about P2 and P4, they both arrived at the same time. So the next chance will be given to the one who have arrived first. And that's why P2 will be given the chance as next. It is having a burst time as 4. 8 plus 4 is equal to 12. After that, P4 was remaining. P4 will have the next chance. It is having the 4 as basically the burst time. So 12 plus 4 will give me answer as 16. So this is called as a Gantt chart for non-preemptive SJF. Now, when you talk about waiting time in this scenario, the waiting time is basically the time which is for P1 when it got the control. Now, the arrival time for P1 was 0. It got the control at 0. So 0 minus 0, that is 0. 1 minute. The outside vehicle noise. Anyways. So when you talk about process P2, P2 have arrived at 8. P2 have got the control at 8. But P2 was having the arrival time as 2. So 8 minus 2 is basically 6. That's why the waiting time for P2 process is 6. If you observe P3, P3 have got the control as 7. So 7 and its arrival time was 4. 7 minus 4 is equal to 3. That is nothing but the waiting time for my process P3. Similarly, P4 have got the control at 12. Its arrival time was 5. 12 minus 5 is equal to 7. This is how you can calculate a SJF non-preemptive process as well as you can calculate the waiting time for them. There was little mistake while explaining in the yesterday, but now I hope you have understood in a proper way. Everyone? Yes or no? Yes. So this is basically non-preemptive SJF, and we have already seen a preemptive SJF in the last class, which is also called as shortest remaining time first. In this case, जैसे ही जो process का arrival time आएगा, at that moment previous process gets preempted. Preempted means from the running queue, it will go into the ready queue once more. That is called as preemption. When do we preempt the process? It is basically when the process may receive some IO request, when the process receives that other process have been arrived and I have to stop it, then I will go for from running to ready state one more time. So that is basically called as preemption. And when the next time the process is getting chance from ready to the running queue, that is the job done by the dispatcher. तो dispatcher background में ये combination of algorithms use करता है to move your processes from your ready to running queue. That is basically called as shortest job first, preemption and non-preemption category. Next, we will see the priority scheduling. So in today's class, first we will observe the other algorithms of this, and then we will see the inter-process communication and deadlock. So a priority number is associated with each process. So let us understand this. P1 is basically having the burst time as 10. P2 is given 1. P3 is 2. P4 is 1. P5 is 5. In this scenario, the priority is given to each process. So how do we solve it? First priority is given to P2. So the lowest number indicates the first priority. अब P2 को priority है 1, तो पहले P2 execute होगा. Now P2 is having the burst time as 1. It will execute from, let us say, 0 to 1. Next, second priority is given to P5. So second P5 will get executed. What is its burst time? It is for 5 milliseconds. So from 1 to 6. The third priority is given as 10. So P1 will execute and 6 to 16. Next priority is given to P3, which is called as only 2 burst cycle. P3 is having 16 to 18. Next, P4 is having the last priority, but it requires only burst cycle 1, so 18 to 19. Now, if you observe and let me know, I'll just take this Gantt chart. I'll just take this Gantt chart and I will take, just a second, right. Now, if you observe and if I ask you, can you please tell me the waiting time for process P1 in this scenario was how much? 6. Waiting time for P2 was 0. Waiting time for P3 is 16. Waiting time for P4 is 18. Waiting time for P5 is, let us say, 1. Right? Now, also if you observe the process which is P4, assume, right? P4 को burst time कितना है? 1. Right? P4 requires burst time or the execution time is only 1. 1 burst cycle के लिए P4 को कितना milliseconds let us say wait करना पड़ा? 18 milliseconds. Right? So, in case of priority scheduling, suppose now what happens? This process, first, let us say, पहला priority था P2 को, priority 1. P5 was given as priority 2. P1 was given priority 3. P3 was given priority as 4. P4 was given priority as 5. Now assume what has happened in between. In between, suppose P1, P2, P5, P1 got executed because of their priority. And in between, there is operating system gives me one more processor, one more, you can say, one more kind of this particular process. And assume I'm saying that is my process PA, which is having the priority, let us say again 3. Assume. Now what will happen in this case? Now my operating system will observe I have got a process who is having the priority 3. I have already waiting process who have priority 4. Obviously, as far as priority scheduling is concerned, तो पहले कौन सा process execute होना चाहिए? Obviously PA, right? Suppose one more time process PB comes. Assume and उसका priority भी अभी 2 है. Is it lesser than this priority? Yes. Again, PB will get executed. P3 and P4 has to wait for it. So what I want to conclude over here is, if the highest priority process comes before the lowest priority process, in that case, some of the processes may have to wait for a longer period of time, and they may never get the chance also. This problem is called as starvation problem. This problem is called as starvation problem. Means my process P3 and P4 both are starving for the processor to get the control, right? So let us understand what is starvation problem. So in case of starvation, low priority processes may never gets executed. So a priority number which is associated with each process, in that case, we go for priority scheduling. Now, in case of priority scheduling, there can be a problem of starvation. अब अगर starvation का problem है, तो I need a solution for it. The solution is aging. What is aging? For example, suppose P2, P5, P1 have got executed. Now P3 is waiting for P3, which is having the priority as 4, and P4, which is having the priority as 5. They are waiting for me. Let us say my P3 process is waiting for from 10 minutes, right? Still, it have not got chance. Again, after 10 minutes, again my operating system will check. After 10 minutes, again my operating system will check. Let us say, is the P3 process is still waiting for me? Yes. So what your processor will do, or what your operating system will do, operating system will try to decrease its priority maybe by 1. Let us say, अब इसकी priority 3 कर देगा, अब इसकी priority 4 कर देगा. Again, maybe after 10 more minutes, OS will observe, oh, this process is still waiting. After some time slot, maybe its priority is getting decreased. Maybe it will decrease its priority. And after again 10 minutes, maybe it will see, oh, P3 and P4 yet not have got the chance. So again, it will decrease its priority. Again, it will decrease its priority, and so on and so forth. So अगर priority 1 पे आ गया, तो obviously वो process फिर execute हो सकता है. So this is a job which is done by OS automatically, and this is basically done so that the processes which were having the lowest priority, with the help of aging, solution to the starvation is aging, तो उनका priority कम होते जाएगा, and that process will not go in the starvation mode. That process will get the processor chance. Have you understood? So these type of questions are asked. In case of priority processing, the low priority processes may never get executed. That problem is called as starvation, and the starvation ka solution is aging. As the time progresses, it increases the priority of the process such that that process will get the chance for this. That is priority. Samajh mein aaya? Everyone. Right. Next is round robin. What about the original priorities? That gets decreased, Rani. That gets decreased. And that job is done by your OS, managing of processes with certain time limit. That's why it is called as aging with some time slot or maybe after some time slot. Right. Next is round robin. In case of round robin, each process gets a small unit of CPU time. That is called as time quantum. For example, suppose I'm saying, let us take example. Which type of questions? Monali, I'm talking about these questions. Okay? Priority scheduling में starvation क्या रहता है? Priority scheduling में aging क्या रहता है? Based on the definition part, the question can be asked. Let us move ahead to the round robin. As the name says, round robin means every process will receive a chance for some processor to get some processor after some time period, line by line, maybe chance by chance. That is called as round robin. Now take an example. Process P1 requires total 53 burst time, 53 cycles लगता है. P2 requires 17 burst cycles. P3 requires, let us say, 68 burst cycles. P4 requires, let us say, 24 burst cycles. So in this case, I have given processes, I have given burst time. My operating system decides how much time will be given to each process for their execution. So maybe my operating system will find, okay, I will give 20 milliseconds to each process for its execution. Now, let me take the same diagram and I will explain over there. This I will save it first.